And now we are live for posterity. You ready? Here we go. This is something called dimensional analysis or unit conversion. And again, let me emphasize Brian, who's going to sit up and have his eyes open. I am not going to give you the easiest method. What I am going to give you is the best method. So bear with me. We're going to start out with something that I hope is reasonably obvious. If A times B equals A, what must B equal? Ooh. If you multiply something by a number and you get the original, that, believe it or not, is one of the most fundamentally profound concepts in math. We have a name for this concept. We call it the identity, or if you really want to sound impressive, the identity matrix. And anything that if you multiply it onto another number, you get the same answer is a 1. But ones can look very, very different. You can write 1 in many different ways. Is this a 1? Yes? Is this a 1? Yes. Okay. The top and the bottom have the same value. And that's really going to be our broader definition of a 1. We're going to use fractions, the math F word, not the F word you're thinking of. We're going to use fractions and conversion factors to dramatically cut down on our memorization and allow us to systematically get places. Ooh, is this a 1? It's a funny looking one, but I'm telling you, 60 seconds and 1 minute have the same value. That's a 1. And what that means is if I were to multiply a number by 60 seconds over 1 minute, even if the answer looked different, it still has the same value as we started. That's going to be our strategy. We're going to make our answers look different, but they're still going to be the same value that we started from. Hey, is 4 quarters over 10 dimes equal to 1? Yeah, because it's 100 pennies over 100 pennies. $1 over $1. So that's the first thing we're going to kind of tuck into our back pocket and save for later. Any fraction equals 1 as long as the numerator, which is the fancy word for the top, and the denominator, which is the fancy word for the bottom, have the same value, Brian, even if they don't look the same. As long as they work out to the same value, that's a 1. Oh, and if you multiply by 1, you're not changing your answer. Maybe making it look different. So, since we're multiplying by 1, our original value won't change. We're going to make it look different. And what we're going to do is we're going to multiply by a series of 1s, funny-looking ones, until we end up with the units we're looking for. We call these strange-looking ones conversion factors. Let me give you an example. Now, none of you have had me before as a teacher. One of the things, Tyler, that I'm really big on is, can I build a habit, a reflex, almost a circuit in your brain where you can write something down mindlessly? Because once you've written something down, since the question is no longer white paper staring at you, you're much more relaxed. The odds of success go up dramatically. And for unit conversions like this, I have a rule. My first step, I always just write down what they gave me. So it says, given that 1 kilogram equals 2.2 pounds, convert 12 pounds to kilograms. What did they give me? 12 pounds. I'm going to write it down, but I'm going to write it down cleverly. First of all, I'm going to write down 12, and my abbrev for pounds, I'm going to use the pound sign because that's easier than writing LBS. I'm going to do one more thing. I'm going to make it a fraction. How can I make any number a fraction? We never bother writing this, but what's every number technically over? So just this once, I'm going to do that. But after that, from now on, can you just use your Sesame Street imagination and imagine that there is an over 1 there, that there's a top and a bottom? Is that okay? Okay. And what I'm going to do is I'm going to multiply by a fraction, by a conversion factor. So draw a horizontal line. It says it wants me to convert pounds to kilograms. What that really is saying is I want to get rid of pounds. Where is pounds in the original fraction here? On the top or on the bottom? Where should I put pounds in my conversion factor if I want it to cancel them? Bottom. I'm going to put pounds right there. Do you know what's going to go on the top? Kilograms, the other unit that they gave me in my conversion factor. But this is not a 1. This would be wrong. You know what a 1 is? Well, Brian, can you read to me right here, starting with the word 1.0?
1.0 equals...
Don't forget units. 1.0 what? Stop. 1.0. Keep reading.
Equals 2.2 pounds.
That goes down there. What you're really saying is that's a 1 because they're both the same thing. They look different, but they're both the same thing. The final rule is if it's on the top, you multiply. If it's on the bottom, boys and girls, what do you think? You divide. Now, technically, I should go 12 times 1 divided by 1 divided by 2.2. Will timesing by 1 and dividing by 1 make a difference at all? We're going to skip those. Get your calculator out. I guess to convert 12 pounds to kilograms, it's going to be 12 divided by 2.2. And I also want you to notice, if I cancel out the pounds, what are the only units that are left behind? That's what I wanted it in. So, did it say go to the correct number of sig figs? Anywhere in the instructions? Then let's decide, unless the question specifically says go to the correct number of sig figs, let's say our default will be 3 sig figs. That's usually enough accuracy. So I'm going to go 12 divided by 2.2, 5.45. I'm going to stop at the 5. Is that 5 going to stay a 5 or become a 6? 5.45 it is. If you wrote that, I would take a half mark off. I'm very fussy. Your final answer always has to have units. What are my final units here? Kilograms. Now, really what I'm saying is this. Kids always ask, Mr. Dewick, if you tell me 1 kilogram is 2.2 pounds, do I want to times by 2.2 or divide by 2.2? I don't know. This method tells me. If the 2.2 is on the bottom, I'm going to. If the 2.2 is on the top, I'm going to. On the top, I'm going to multiply. I know you're tired. That's why I keep coming back on you. Let's do the next one. It says convert 64 kilograms to pounds. You know what I'm going to do first? Write down what they gave me. 64 kg. I'm not going to write the over 1. I'm going to imagine that it's there, if you don't mind. Times. I want to get rid of kilograms. Where am I going to put it in the next fraction? By the way, what if kilograms was on the bottom of the first fraction and I wanted to get rid of it? Where would it go in the next fraction? On the easy peasy. And on top, pounds. But this is not the correct conversion factor. What's my conversion factor that Brian read for us earlier? Apparently, 2.2 of these is one of those. Am I going to multiply by 2.2 or divide by 2.2? So it's going to be 64 times 2.2, which is what? I get this in my head. Sure I can. 64 times 2 is 128. It's going to be 128 plus 12.8. It's going to be 120. It's going to be 140.8. You know what? Since I did it in my head, I'm going to go to 4 sig figs. Nope. I went 128 plus, I know that 64 times 2 is 128, so I also know that 64 times 0.2 is 12.8. So I went 128 plus 12.8. 128 plus 12 is 140, plus 0.8, 140.8. I did the math in my head. I can do math in my head. I can do math in my head. Most of you can. I grew up without a calculator. If you said 141, Tyler, I'm totally showing off because I got 4 sig figs in my head, so I got to brag. Next page. Now we're going to use the green sheet, the back page. Metric prefixes can be worked like this as well. Now, you may have a shortcut for doing metric prefixes, and as long as you keep getting the right answer, go ahead and use it. There are all sorts of gimmicks and shortcuts. I'm again a big Sauron, Mordor, ring of power, one ring to rule them all person. I'm going to use the same method. So this says, Ella, convert 12, oh, what's a capital M? Megagrams to grams. Anybody want to guess what I'm going to do first? Write down what they gave me. 12 megagrams times fraction bar. Ella, what do I want to cancel? I guess megagrams. Where is it going to go in my next fraction? On the? Yep. What units do I want left behind? Just plain old grams. But this is not correct. This is not a 1. Mega, 10 to the what? I think it's 6. Okay, where does the 10 to the 6th go? You don't memorize, it goes on the top. You don't memorize, it goes on the bottom. You know what you memorize? It goes where the mega isn't, where the metric prefix isn't. It doesn't go there, it goes there. Because what we're really saying is 10 to the 6th and mega are the same thing. That's the one. Ooh, cancels. And here's the real question. Am I going to times by 10 to the 6th or divide by 10 to the 6th? Where is the 10 to the 6th? On the times. So, 12 times 10, exponent button, 6. And I get a 1, a 2, and 6 zeros. Which, if you wrote that, I would give you full marks. But is it going to be less work to write that in scientific notation or in standard form? I'm going to, because I'm lazy, choose to write this in scientific notation. Since they didn't say, I can choose. 1.2 times 10 to the, don't say 6. Ella? 1.2 times 10 to the? 7. Good. And then don't forget the units. Okay. Now, this was going from a metric prefix to no metric prefix. I can also go from no metric prefix to a metric prefix. Aaron, any guesses on how I'm going to start? Write down what they... 13.6 amps. Multiply. I guess I want amps to cancel. Where's it going to go in my next fraction, Aaron? On the top or on the bottom? Yep. You know what's going to go on the top? Milliamps, except I'm not done. This is not a 1. I need to change it into a 1. What's milli? 10 to the what? Where is the milli going to go? I don't memorize top or bottom. Where the milli isn't, which in this case is on the... The milli is on the top already, Gerard. Where the milli isn't, which in this case is on the... That's what I memorized, not top or bottom. It goes where the metric prefix isn't, because milli and 10 to the negative 3, that's the one. So Aaron, am I going to times by 10 to the negative 3 or divide by 10 to the negative 3? And it answers that question for me because it's on the bottom. Get my calculator out. 13.6 divided by 13,600? Or 1,360? It's one of those two. 13,600, yes? Yep. Is it easier to write that longhand or scientific notes? I think longhand is shorter to write it, so I'm going to write it 13,600 units, Aaron? Yep. Yep. I call these one-step questions because, Oliver, one step. A two-step question is like number 3, where you're going from one metric prefix, kilo, to another metric prefix, micro. Anybody want to guess how many steps it's going to take? 2. What I'm going to do first is get rid of kilo, step 1. And then I'll bring in micro, step 2. But what I'm really going to do absolutely first is what? There's a common theme here. What? I'm going to write down what they gave me. I love it if I can write something down mindlessly. Have I written something down? Am I more relaxed? Do I feel better? Is the odds of success increased? Absolutely. Okay. Step 1, get rid of kilo. Okay, Gibson, what am I going to put on the bottom? Yep. What am I going to put on the top? Not micro yet. I'm not dealing with that. I'm just getting rid of kilo. Plain old grams. And kilo is 10 to the... It's on your green sheet. Where's the 10 to the 3 going to go? Where the kilo isn't. If I stopped here, that would be grams. But Gibson, what do I want to end up with? What's that thing called? Micrograms. So, step 2. Step 1, get rid of kilo. Step 2, okay, I guess grams is going to go on the bottom now. Yes? Micrograms is going to go on the top. Oh, micro, 10 to the what? Where's the 10 to the negative 6 going to go to? Where the micro isn't, which in this case is on the... The micro isn't on the top? You understand what I mean, folks? It goes where the metric prefix is not, which in this case is on the bottom. Okay? What we're saying is micro and 10 to the negative 6, that's our 1. Don't put it beside it. The other level of it. I guess I'm going to times by 10 to the 3rd and divide by 10 to the negative 6. Okay. Try typing this on your calculator, please. This isn't scientific notation, even though it has 10 to those. I'm not using my scientific notation button. I'm just typing it as is. I think you're going to get a fairly big answer. You might, depending on your calculator, even get an answer in scientific notation. I picked this one so it's right on the threshold, depending on which calculator you have. Am I right? Is some of you getting an answer in scientific notation? I got a typo, first of all, Mr. Dewick. It's 10 to the negative 6. I haven't hit equals yet. I got that. Yes? I'm seeing nobody nodding, so I don't know what's going on here. I got 1.3 times 10, 1.36 times 10 to the 10. Yeah. Yeah, that's the right answer. I can do a lot of these in my head. Okay? Or you might have a 1, a 3, a 6, and 8 zeros. Although that would mean your calculator has an 11-character display, which is unlikely. If you did not get that, let me pause for a second. This one will be shorter to write in scientific notation, but I'm not going to write 1.36 letter E 10. I'm going to write 1.36. I know on my calculator that letter E means times 10 to the 10th units. Gibson, did it work? Because you look like... Okay, let me pause again. Number 4. Nanoliters to megaliters. Logan, what am I going to do first? There's a common theme that we've been doing here for unit conversions. What's the first thing I'm going to do without even thinking about it? Write down what they... What am I going to write first? Write down what they gave me. Right? You with me? I know, you're playing catch. You're back? So, Logan, I'm going to write 2,000 nano... Oh, look up. Why would I never write a lowercase l like that? What number does that look like? So I will always, for liters, write a cursive L. And you can even see in the font, I changed the font and I found an L that was cursive, so you can tell it's not a 1. You okay with that, Logan? All right. This is a 2-step. How can I tell at a glance that this is a 2-step? We're going from one prefix, nano, to another prefix, mega. What's step 1, Logan? I want to get rid of nano. So here's my fraction line. What's going to go in the bottom of the fraction? Yep. On the top, just plain old liters. But I need now on the top, where the metric prefix isn't, which in this case is on the top. What is nano? 10 to the what? I'm letting other people make sure they can find these things too. That's why I kind of call on kids. Negative 9? Yes? Oh, good. And again, I don't put the 2,000 in the bottom or anything. This is good. If I stopped here, that would be liters. Do I want to stop with liters? No. Step 2. Now I'm going to bring in mega liters. I can do this. What's going to go in my next fraction? Well, I need to get rid of liters. So it's going to go on the... Yep. And on the top, mega liters. Except I'm not done. I need to bring in the power of 10. Logan, what power of 10 is mega? Ten to the positive 6. Where is the 10 to the 6 going to go? Top or bottom? You're right. How do I know? Because it goes where that's the metric that isn't. In this case, it's on the bottom. Good. I guess it's going to be 2,000 times 10 to the negative 9 divided by 10 to the 6th. Which is what? Negative 9. 2,000 times 10 to the negative 9 divided by 10 to the positive 6. I think you're going to get an answer in scientific notation, I suspect, because I think it's a pretty small decimal. What'd you get, Logan? See, I know you hadn't started typing yet. This is why I'm coming at you. And I know you're having to work with that calculator. You might want to remember what I'm saying. In my head, there's 3 zeros. There's negative 9, so that's going to be negative 6. It's going to be 2 times 10 to negative 12. Is that right? Yeah. That was easier than you realized because I was only having to deal with the powers of 10. Mega liters. Is that what you got as well, Logan? Good. Okay. Is this a 2-step question? Everybody try this on your own. I'll do it up here without talking. If you get stuck, look up. But if you can do it on your own, then there's going to be about 3 or 4 of these on your test. Should be easy marks as long as you can type on your calculator. I wrote my answer in scientific notation, but you don't have to. I might be wrong. I did it in a hurry. Colton. Oh, keep going. Okay. So I got 3, 4, 2, 5, and then 5 zeros after that. And then I wrote it in scientific notation because I'm lazy. Units matter. Turn the page. Put your pencils down, look up. I'm going to play for you an audio recording. Put the cube away. I'm still teaching. I'm I'm going to play for you an audio recording of a phone call. This is a phone call that a guy made to Verizon. See if you can figure out before the Verizon operator what the issue is. See if you're too smart to go work for Verizon. Phone company in the U.S.
Hey, have you been using my account handset? It's really convenient. You can check your balance, see your unbilled minutes, and messaging you, make payments.
All right, hey George.
Yes.
Hey, I'm really sorry about that. Hey, I got Mike up my supervisor over here. You take care of you. Okay.
Thanks. Yes.
Thanks, Trent. Good evening, George. How are you doing this evening?
Great. Except that I've been trying to resolve this for 2 calls in over 45 minutes now.
So here's the backstory. He's already been on the phone for 45 minutes. This is the third or fourth person that he's been talking to, trying to explain something. So he's about to explain something. Listen close. See if you are smarter than someone who works for Verizon.
Well, let's see what we get. Not here. I'm definitely not here. You've had a call on that many times. Let's see. Looks like you're requesting some kilobyte usage that was done while in Canada.
Well, let me just start out with a basic question. Do you recognize that there's a difference between $0.002 and $0.002 cents?
$0.002?
Do you recognize that there's actually yes? Do you recognize there's a difference between those two numbers?
No.
Okay, is there a difference between $2 and $2.02?
Well, yes, there is.
Okay, so is there a difference between $0.002 and $0.002 cents?
$0.002.
Yes. Is there a difference between?
They're both the same if you look at them on paper-wise.
No.
So he had some fun with this. This was one of the very first YouTube, wasn't a video, it was an audio recording, things to go viral. This is from right around 2007. So George started selling T-shirts that said they're both the same if you look at them on paper-wise, because that was such a great quote. What's Verizon doing? Not looking at the units. Verizon is doing that. That makes a huge difference. The backstory here, George was quoted a roaming, he's from the U.S., he was quoted a roaming rate in Canada of 0.002 cents per kilobyte. But because Verizon didn't include units in their billing when they typed it in, they've charged him $0.002 per kilobyte. Instead of a $3.70 bill, he's got a $370 bill. You all get it, yes? There is a difference between $0.002 and 0.002 cents. You spotted it right away? Okay, Gerard, you're near the very, very front. Can you look at the timestamp in the bottom right corner here? How long does this call go for? How many more minutes? In 22 more minutes, yeah. In the middle, he gets passed to another manager who's snotty with him, who accuses him of trying to mislead their employees with tricksy math and number game. This goes on and on. He blogged about this in his website. When this went viral, a whole bunch of other customers started looking closely at their bill. Hey, yeah, Verizon's done the same thing to us. And so a class action lawsuit was launched. Eventually, Verizon settled with him, but he showed the letter they sent him. Even in the letter, they refused to admit that they were wrong. They said, oh, you were clearly confused by what we said, but we're tired of the publicity, so here's your money. No! Aaron, there's a difference between $0.002 and 0.002 pennies. A huge difference. Units matter. If you forget units or if you have the wrong units, there's a very good chance in the future that I might hand you an application to go work at Verizon. That just may be my way of politely reminding you. Yes? $0.002 is actually 0.2 of a cent. Part of it was Verizon, because they wanted to make it sound cheaper, picked stupid units. 0.002 cents per kilobyte. They should have gone dollars per megabyte, which would have been way clearer. But they figured with cents, People will think that's cheaper and they'll buy, right? Now you might say, oh, Mr. Do It, people aren't that dumb. Then I took a deep dive in Twitter this summer. This was one I found on Twitter. This got retweeted several thousand times. There are 21 million penguins in Antarctica. And the population of Ireland is 6.6 million. So if all the penguins in Antarctica decide to invade Ireland, each person would have to fight off over 3 million penguins. Is that correct?
No.
Wait a minute. 21 points. Of course it's correct. Look. 21.6 divided by 6.6 is 3.3. Isn't that 3.3 million? No. The millions would also cancel when you divide. That wasn't the one that made me crazy. It's this next one. This is from a professor, and I tracked him down because I thought this has got to be fake. No, he teaches at a university. Musk spent $44 billion on Twitter. The world's population is 8 billion. He could have given each person $5 billion and still have money left over. I feel like a check for $5 billion would be life-changing for most people. Yet he wasted it all on Twitter. I should point out the only true statement in this whole is that sentence there. That statement is true. $5 billion for every human being would be life-changing. Although it would probably throw the economy into chaos because now that would be the average wage and very quickly everything would just get crazy more expensive. What's the problem here? Is this right? Again, he went 44 divided by 8, 5.5. But he didn't cancel out the billions. There are so many of these. I watch the news and I catch these all the time. Many journalists are not that good at math. I got to calm down now, Brian. I go crazy at this stuff. I really do. Okay. C. Multi-step conversions using conversion factors. I like example 6, I like example 6, I like example 6, example 6 is the next question. Why would I say that? No. Why would I say that? Why would a teacher emphasize a certain question? You're good academic students. Why would a teacher emphasize a certain question? No. Why might I emphasize a certain question? What hint might I be giving you? Gerard, speak to me, brother. What?
Maybe the questions on the test.
Did you hear me say it's going to be on the test? Or you're the kind of student that notices when a teacher tends to emphasize certain things? Good. I like this question. I like this question. Pick up one here. How many seconds in 1 week? First of all, maybe someone knows. Does anybody know how many seconds are in 1 week? Because if you know it, you can go straight to the answer, obviously. Okay. Logan, you know what I'm going to do first? Write down what they gave me. What did they give me? 1 week. What's a good abbrev for week, Ella? I'm good with that. I'm going to write down 1W. The really nice thing about this conversion factor method is that you can use stuff that you've already memorized without trying. Let me show you what I mean. What can you break weeks down into? Do you know how many days are in a week? And I don't need to make you memorize that. You already have, because you're an adult almost. Just from growing up, you've picked up certain things. Okay. Where do I want weeks to be in my conversion factor? On the days on the top. And the conversion factor here is 7 days is 1 week. Or if you wanted to have fun, you could go 14 days is 2 weeks, because that's a 1. You could go 21 days is 3 weeks. I usually just use the simplest one. If we stop there, what would be in? What do we want to be in? No, what do we want to get to? I'll ask. Does anybody know how many seconds are in a day? Because if you did, you could go straight to the answer. What can I break days into? And you've memorized this just because you're almost an adult. You all, I assume, know how many hours are in a day? I don't need to make you memorize that. Good. Where's days going to go, Bottom, hours, and I guess it's going to be 24. 1. Do you know how many seconds are in an hour?
1,000.
Nope. And nope. So, because nobody got it the first time, we'll just have to keep doing this the long way. What can I change hours into? And I've memorized how many minutes there are in an hour just because, again, it's a functional skill. So I can say hours will cancel. Why would that be a bad abbrev to use for minutes? Okay. Why would that be a bad abbrev? That's miles in the U.S. The abbrev for minutes, sorry, it's MIN, and it's going to be 60 minutes is 1 hour. Can I break minutes into seconds? Oh. Minutes, seconds, 61. Now, you might be saying, Mr. Dewick, I could have kind of figured that out on my own. But the question students always ask is, well, am I going to times by 60 or divide by 60? Where are the 60s, on the top or on the bottom? It's pretty obvious. I'm going to multiply 24 times 60 times 60. This answers that for you. You don't need to ask, am I dividing or am I timesing? Pops right out. And you don't have to memorize crap. What do you get? 7 times 24 times 60 times 60. How many seconds are there in a week?
604,000.
Read me the digits. 60.
604,802. 11 times.
Is that right?
What was I supposed to take?
I don't know.
But I did 24 times 6 times.
Did you forget? Did you get the 7? Well, there's a 7 sitting there. You ignore the ones.
604,802.
Yep. Yep. Okay. So conversion factors let you tie into stuff you've already memorized. It really can bail you out of a lot of stuff. Number 7. I like number 7. I like number 7. I like number 7 is a nice question. If you haven't figured out what I'm really saying is, in the future, you can probably be expected to convert some type of time into another unit of time using stuff you've already memorized. Jesse, what am I going to write down? More specific. Now, look up. I won't take marks off, but I'm a nerd. The proper abbrev for year, don't write this down, is not Y. Y is taken by the US for, think football. It's yards. The proper, if you write a Y for year, I won't take marks off, but I'm a nerd. I have to do it right. The correct abbreviation for year is a lowercase a for annually, because Y was taken. But by the way, I strongly encourage you, learn to abbrev. Don't write the word year. Do yourself a favor. All right. Jesse, what can I break years into? Have you memorized how many days there are in a year? I think all of you have. Because science. How many days are there in a year? How many days are there in a year? They just said it. You weren't listening. 365. Okay? I wouldn't use 52 weeks because it's not exactly 52 weeks. It's 52 weeks and change. But a year is defined as 365 days. So that one we're good with. So I'm going to, oh, Jesse, where is years going to go? Top or bottom? Yep. On the top, days, and a 365 on the top and a 1 on the bottom. Times. If I stop here, I would be in days. Oh, do you know how many hours in a day? You know that one? And I can get, oh great. So where am I going to put days, Jesse? Top or bottom? Hours on the top, 24. And I guess it's going to be just, 365 times 24, which is what? And again, this answers the question because kids ask, look, I know it's 365 and 24. Do I times them or do I multiply them? The fractions tell you what to do. Jesse, what'd you get? 8760? Good. We're almost done and I'm going to hit pause. We're almost there. Joshua, do you know how many seconds are in a year? Because if you did, you could go straight to the answer. Okay. What am I going to do first? Write down what they gave me? 1 year, baby. What can I convert years into, Josh? If I'm paying attention, if I happen to notice what I've just written, if I'm clever and not just mindlessly drooling, what could I convert years into and save myself some time if I was clever? Don't be scared to use an answer from earlier to save yourself some time. 8,760 hours is 1 year. Now, does anybody know how many seconds are in 1 hour? No, it's 60 minutes in 1 hour and 60 seconds in a minute. It might be worth knowing that there's 3,600 because it's 60 times 60. Let's try using that as a little shortcut. We can say 3,600, and lo and behold, every year contains 8,760 times 3,600. I'm ignoring you. Give me a second. I know where I'm going. Patience, grasshopper. 31536 and 3 zeros. There's always, and this is what I told you, I'm not showing you the easiest way. I'm showing you the way they'll always work, and we're going to get into yuckier questions where your easier method won't work. But if you know of other ways to do this and you're always getting the right answer, I'm fine with that. What I'm saying is, I've never bothered memorizing 5 or 6 different tricks when I got one thing that works and I can do it in my sleep. Oh, why would I lose a half mark here? One of the other nice things about this is the units checking out will let me know if I've done it right. Those cancel, only seconds is left. Yep, I must have done it right. Mr. Duick's unit conversion method. Step 1, write down what they gave me and write it as an implied 2-level fraction so you know there's an invisible little 1 there. Step 2, look at the units and find a conversion factor with those units. If the original units are on top, they're going to be in the bottom of the conversion factor. What about if the original units are on the bottom? Yep. Cross out the units when done to see which units are left. If we have a table of conversion factors, we're going to pause here. Your homework, there's about 7-8 minutes left. You can try working on the take-home quiz. You might get it done in class if you hustle. And we're going to pick up with this tomorrow. You want to make sure you have a calculator with you tomorrow.